Okay, hello everyone. Today I want to talk about the review for derivative integrals and improper integrals in chapter 6 and chapter 7. The first one, you need to memorize differentiation formulas. C prime equals 0, x prime equals 1, x to the power n prime is n times x to the n minus 1, c times f prime is c times f prime, f plus or minus g prime is f prime plus or minus g prime, f times g prime, we use the product rule, f prime times g plus f times g prime, f over g prime. You can use a quotient rule, f prime times g minus f times g prime over g squared. Sin x prime is cosine. Cosine of x prime is negative sine. Tangent x prime is secant square of x. Cotangent x prime is negative cosecant square of x. The secant x prime is secant times tangent. The cosecant prime is negative cosecant times cotangent. You need to know chain rule. F of g of x prime is f prime of g of x times g prime of x. The power rule combined with the chain rule, g of x to the power n prime is n times g of x to the n minus 1 times g prime of x. We need more differentiation formulas. ln of x prime is 1 of x. ln of g of x prime is g prime of x over g of x. The log x with base a prime, you can use change of base. You can change ln of x over ln of a from log of x with base a. The next, you can find this answer. Because how can you find this one? This part is exactly same. 1 over the ln of a times ln of x prime. You can take out constant 1 over ln of a. You can take out 1 over ln of a times ln of x prime. This is same to 1 over ln of a times ln of x prime is 1 over x. So we have this result. Like this. The next one, the e to the x prime. What is e to the x prime? Do you know? If you know e to the x prime, could you write answer on chatting board? What is e to the x prime? Yes, thank you, Lin. So e to the x prime is like e to the x. So we have it. So e to the g of x prime is e to the g of x times g prime of x. So we use chain. A to the x prime is a to the x times ln of a. A to the g of x prime is, you can use chain rule again, a to the g of x times ln of a times inner function prime, g prime of x. The inverse sine of x prime is 1 over the square root of 1 minus x squared. Inverse cosine of x prime is minus 1 over square root of 1 minus x squared. Inverse tangent of x prime is 1 over 1 plus x squared. Inverse cotangent x prime is minus 1 over 1 plus x squared. Inverse secant of x prime is 1 over x times square root of x squared minus 1. Inverse cosecant x prime is minus 1 over x times square root of x squared minus 1. So how can you find the derivative of inverse of f? So we use one theorem. If f is a one-to-one differentiable function with inverse function inverse of f and f prime of inverse of f of a is not equal to 0. So we have this result. The inverse function is differentiable at a. Inverse of f prime of a is 1 over f prime of inverse of f at a. This is like one good result. We try to solve this problem. F of x equals 3x plus cosine 2x. We can find inverse f prime of 1. The first one, you need to check. Function f is 1-to-1. What do you think? The f of x equals 3x plus cosine 2x is 1-to-1. This is 1-to-1. So what do you think? Is it 1-to-1? So how can you know this kind of things? So we use this idea. F prime of x is 3x plus cosine 2x prime. So 3 minus 2 times sine 2x. So what happens? This is always positive because what's it like sine 2x? Sine 2x is always between minus 1 and 1. So one more, you multiply by negative 2. You multiply by negative 2. So multiply by negative 2. So like this. So what happens? Negative 2 sine 2x is, you need to change inequality. Change inequality. So negative 2 times minus 1 is positive 2 here. So 1 times minus 2 is like negative 2. So next, you need to add 3 to each side. You add 3 to each side. So what happens? 3 minus 2 sine 2x is less than or equal 2 plus 5 is 3 is 5. The negative 2 plus 3 is like 1. So what happens? Always positive number. So this is what? Always positive. So we have this one. So what does it mean? Function f is increasing. F prime of x is positive. F is increasing. Increasing function is always 1-to-1. So we can follow these steps. So what's that? You can use formula. This is same to what? 1 over f prime of inverse of f at 1. You can use it. What's step 1? Find inverse f of 1 is first. Next, find f prime. The last one, reciprocal. This is like a whole idea. First one, we think about inverse f prime. Sorry, inverse f of 1. This one, step 1, inverse f of 1. You can use definition. It's exactly same to 1 equals f of x by using definition of inverse function. So what's it like f of x? This f of x is 3x plus cosine 2x. You can replace. So you need to guess what is x. What is x? So what do you think? So what is x? Do you have any idea? So what is x? You need to solve this equation for x. Only guess. Yeah, x equal to 0. Thank you. So here, x equal to 0. Why? You plug 0 into here. So what happens? 1 equals 3 times 0 plus cosine of 2 times 0. So this is 1 equals cosine of 0. The cosine of 0 is 1. Yes. So x equals 0. We have it. So like this. So inverse of f of 1 equals 0. The next thing, you plug this number into here, 0. You need to calculate f prime of 0. So you plug 0 into here. You plug 0 into here. You calculate f prime of 0. The 3 minus 2 times the sine of 2 times 0. Sine of 0 is like 0. We have 3. The last one. Here, find exact things. What's that? The reciprocal of 3, the 1/3. This is final answer. This is the whole idea for solving this problem. The next thing. The differentiate f of x equals ln of cosine square of 3x. The g of x equals 1 over arc sine of e to the power 3x. What's it like arc sine? Arc sine is exactly same to inverse sine. This inverse sine, this exact meaning. Here, first one, f prime. How can do that? The first one is 2 is like down, because ln of x to the power r is, the power r is like down, the r times ln of x. This is like a reason. So 2 is like down. The next, take the derivative, ln of cosine 3x prime. So we can use this idea. 2 times cosine 3x prime over cosine 3x. So why this is true? Because ln of g of x prime is exactly same to g prime of x over g of x. We can use this idea. So calculate. Cosine 3x prime is like negative sine 3x times inner function prime. So this is same to negative 3 sine 3x. So combine. This is negative 6. Sine of cosine is tangent. We have a negative 6 tangent 3x. G prime of x. 1 over arc sine e to the 3x prime. So you can change it to the power form. Arc sine of e to the 3x to the minus 1 prime is, you can use power rule. The minus 1 is down. Arc sine of e to the 3x to the power minus 1 minus 1, negative 2, times inner function prime. Arc sine of e to the 3x prime. So next thing, you have to keep this one. Find arc sine e to the 3x prime. How can do that? We can use this idea. Arc sine of x prime is the same to 1 over square root of 1 minus x squared. You can plug e to the 3x inner function into here. Inner function into x. So we have it. Times inner function prime. This is like a chain. So next, we have this result because this one prime is itself times power prime. So we have e to the 3x times 3. We have 3 times e to 3x. Next, change. So this is minus 1 times 3 times e to 3x is negative 3 e to the 3x. You can change negative exponent to the positive exponent by using reciprocal. You can keep 1 over the square root of 1 minus e to the 6x. So this is the idea. The next one, logarithmic differentiation. The logarithmic differentiation is used for finding derivatives of complicated functions involving products, quotients, or powers. Or f of x equals g of x to the h of x. We have exponential function. The base is function. Power is function. We use logarithmic differentiation. The example, f of x is x plus 2 to the 4 times the sine square of x over cube root of x. This is the complicated functions involving products, quotients, or powers. Where f of x equals square root of 2x minus 1 over 2x plus 1, same. This is complicated functions involving products, quotients, or powers. The y equals ln of x to the power 1 of x. So this is the same to f of x equals g of x to the h of x. So we use logarithmic differentiation. So we follow 3 steps. Step 1. Take natural logarithms. The natural logarithms is like ln. Take ln of both sides of an equation y equals f of x. And use the laws of logarithms to simplify. What's it like laws of logarithms? So like this. This is ln x times y. You can change it to the ln of x plus ln of y. The ln of x of y form, you can change it to the ln of x minus ln of y. Ln of x to the power r form, r times ln of x. This is exactly laws of logarithms. We can use this one. Step 2, differentiate implicitly with respect to x. Step 3, solve the resulting equation for y prime, like f prime of x. This is like a whole idea. I'm going to give one example. The last one, y equals ln of x to the 1 of x. What's the step 1? Take ln. Next, the 1 of x is like a power. Power is down. 1 of x times ln of x. Same to ln of x over x. Step 2, take derivative. Ln of y prime equals ln of x over x prime. You can use quotient rule. ln of x, the top one prime times second one minus ln of x times x prime over x squared. Don't like this. So here, don't like this. Oh, this one. And then y prime is exactly y prime of y. The next thing, what is ln of x prime? So ln of x prime is ln of x prime over ln of x. So x prime is 1. So just ln of x times 1 is ln of x. So next one. The ln of x prime is, sorry. The ln of x prime is 1 over x. So we have it. The next, cross out x, we have the simple form. This is this is like complicated like form. So you can change to the simple fraction. This is like a complex fraction. You can change it to the simple fraction. How can you do that? You multiply the top and bottom by denominator ln of x. You can multiply the denominator ln of x. Next, distribute ln of x. Here, so first one, ln of x is crossed out. We have it. Second one, ln of x times ln of x is here. So ln of x times x squared is x squared ln of x. Step 3. You multiply the both sides by y here. So y prime of y is this one. You multiply the both sides by y, like this. So we have it. The next one, y prime is crossed out, y times 1 minus ln of x times ln of x over x squared times ln of x. You can plug back. Y equals ln of x to the 1 of x. You plug into here. So we have this one. So we have it. Okay, this is our idea. The next one, integral k dx. So do you know what's integral k dx? Do you know what's integral k dx? So could you write new answer on chatting board? Yeah, thanks. The kx plus c. This is like improper integral. The x to the n is 1 over n plus 1, x to the n plus 1 plus c. In this case, n is not equal to minus 1. So do you know what's integral 1 of x dx? Do you know what's integral 1 of x dx? What is integral 1 of x dx? So do you know? Integral 1 of x dx is, yes, thank you, ln of x plus c. The integral g prime of x over g of x dx is the ln of absolute value of g of x plus c. Integral e to the x dx is e to the x plus c. Integral e to the kx dx is 1 over k e to the kx plus c. Integral a to the x dx is a to the x over ln of a plus c. Integral sin x dx is the negative cosine x plus c. Integral cosine x dx is sin x plus c. Integral secant square of x dx is tangent x plus c. Integral cosecant square of x dx is negative cotangent x plus c. Integral secant x tan x dx is secant x plus c. Integral cosecant x times cotangent x dx is negative cosecant x plus c. Integral tangent of x dx is the ln of absolute value of secant x plus c. Integral cotangent x dx is ln of sin x plus c, but you don't need integral cotangent. You don't need to memorize. You don't need it. Integral secant x dx is, yes, you need to memorize. ln of absolute value of secant x plus tan x plus c. Integral cosecant x dx is ln of absolute value of cosecant x negative cotangent x plus c, same. So you don't need memorize. You don't need it. The next integral 1 over the square root of a squared minus x squared dx is inverse sine of x over a plus c. So automatically integral 1 over the square root of 1 minus x squared dx is inverse sine of x plus c. We have simple form. In this case, age 1. The next one, integral 1 over a squared plus x squared dx is 1 over a inverse tangent of x over a plus c. So similarly, you can replace a by 1, 1 plus x squared dx is the inverse tangent of x plus c. So we have this result. The strategy for integration, type 1, integral f of x times g of x dx, where f of x times g of x is a product of a polynomial and transcendental function, or two transcendental functions, use integration by parts. So integral u dv is u times v minus integral v du. Question. How do you choose u from the integrand of an integral? So use principle of precedence for u. L-I-A-T-E. So this is whole idea, L-I-A-T-E. The remark, you can interchange L and I. So what does it mean? I-L-A-T-E. It doesn't matter. It's fine. Type 2. integral sine to the power mx cosine nx dx. How can you solve? We have three cases. Case 1, power m. The m from sine function is odd power 2k plus 1. Step 1, save one sine factor. Step 2, you can use u substitution. What is u? Do you know what is u? In this case, save one sine factor. So what is u? In this case, u is, do you know what is u? The u is opposite one. So we have this one. The u is like, yep, you're right, cosine of x. So du is cosine prime negative sine x dx. You multiply the both sides by minus 1. Negative du equals sine x dx. Next, you need to change sine function to the cosine function by using this identity. Sine square of x is 1 minus cosine square of x. So you can plug this u into here, 1 minus u squared. Second case, n equals 2k plus 1. The power n from cosine function is odd power 2k plus 1. How can you solve? So similar, like an opposite way. Step 1, save 1 cosine. Step 2, use substitution. In this case, u is sine of x. du is sine prime is cosine x dx. Step 3, you have to change cosine function to sine function. The cosine square of x is 1 minus sine square. You plug u into here, 1 minus u squared. Step 3, the m equals even power, n is even power. Both are even powers. How can you solve? Step 1, you can use half angle formula. What's half angle formula? Sine square of x is 1 over 2 times 1 minus cosine 2x. Cosine square of x is 1 over 2 times 1 plus cosine 2x. So one more. What is sine square of 2x? In this case, you plug 2x into x. So you plug 2x into x. So we have 1 over 2, 1 minus cosine 2 times 2x is 4x, like this. Similarly, the cosine square of 2x is same to what? 1 over 2, 1 plus cosine 4x. The same idea. You plug 2x into x. You plug 2x into x. So we have this result. So step 2. You can find integral cosine kx. Integral cosine kx is exactly same to 1 over k sine kx plus c. Type 2, integral tangent to the power mx secant to the power nx dx. How can you solve? So we have 3 cases. First case, power m from tangent function is odd power 2k plus 1. Step 1, save 1 secant x tangent x. You can use u substitution. U is secant. du is secant tangent. This is the reason. Why do you save secant tangent? the du is secant tangent. In this case, u is secant. Step 3, you can change the tangent function to the secant function. Use identity secant square of x minus 1. So this is u square minus 1. Case 2. Power of secant function is even power 2k. Step 1, save 1 secant square of x. Step 2, use substitution. Sorry. u equals tangent, du is secant square of x. Step 3, use identity. Secant square of x is 1 plus tangent square of x. You plug u into tangent, 1 plus u square. Case 3. Other cases, we don't have a guideline. The guidelines are not as clear-cut, so we don't have it. So just problem by problem. So case by case. So next one, type 3, integral f of x dx, where f of x contains the following expression here. A squared minus x squared. In this case, you have to use the trigonometric substitution. Here, x is a sine theta. In this case, you have to use identity. 1 minus sine squared is cosine squared. The a squared plus a squared form, so you can use x is a tangent theta. In this case, you have to use this identity. 1 plus tangent squared is secant squared. X squared minus a squared is form. X is a times secant theta. So we use secant square of theta minus 1 is tangent square. The next, how can change back theta to the x variable? We use identity here. So divide by a, so like this, crossed out. Sine theta is x of a. So here you can draw triangle. You can find x over a. How can you find the square root of a squared minus x squared? We use Pythagorean theorem. The second case, divide by a from both sides, a is crossed out. Tangent theta is x of a. You can draw triangle. Tangent theta is opposite over adjacent. How can you find hypotenuse? We can use Pythagorean theorem. The third one, similar. Divide by a is crossed out. Secant theta is x of a. What is secant theta? Here. Hypotenuse over adjacent, like the definition of secant theta. How can you find opposite? You can use Pythagorean theorem. This is like a whole idea for solving these problems. Okay, so type 4. Integral nx over dx. So what does it mean? This is integral of rational function, integral of polynomial over polynomial. How can you calculate? Step 1. You can compare top-on power, bottom power. This is top-on power n, bottom power m. You can compare. The bottom power is greater than top-on power. Just to use partial fractions. Second case, top-on power is greater than bottom power or equal to bottom power. We use long division and partial fraction. The next, you can define integrals by using useful integrals. Integral 1 over x dx is ln of absolute value of x plus c. Integral g prime of x over g of x dx is ln of absolute value of g of x plus c. Integral 1 over a squared plus x squared dx is 1 over a inverse tangent of x of a plus c. Integral x to the power n dx is 1 over n plus 1 x to the n plus 1 plus c. This is like idea. So you need to know double angle formula. This is very useful. Sine 2x is 2 times sine x cosine x. Cosine 2x is cosine square of x minus sine square of x, 2 cosine square of x minus 1 or 1 minus 2 sine square of x. Type 5. 인tegral f of x dx, f of x is nth root of ax plus b or nth root of g of x. First, try to use the substitution rule by u equals ax plus b or u equal to g of x, like in the function. If it is impossible to use this one, you can change u equals whole nth root of ax plus b or u equals nth root of g of x. The summary. How to evaluate the integral? We can use this idea. Integration formulas, substitution, integration by parts, trigonometric substitution, or partial fraction. We have 5 methods for solving integral problems. You can try. Here. So let me see. Which method is possible for solving this problem? Which method? Integration formula, U substitution, the trigonometric substitution, partial fractions. So which method is possible for solving this problem? Which method? Do you have any idea? Which method is possible for solving this problem? What's that? We have 5 methods so far. The first one, integration formula, the substitution rule, integration by parts, the trigonometric substitution, the last one, partial fractions. We have 5 methods. So which method is possible for solving this problem? So do you have any idea? So which method? So in this case, yes, U substitution. You're right. What is U? So what do you think? What is U? So what is U? Do you have any idea? So what is U? 9 plus 4x to the 4, we have trouble. Here, U equals 9 plus x to the 4. You can find du. The du is 9 plus x to the 4 prime 4x cubed dx. But we have only x dx. This is x cubed. So what's the best way? So how can you eliminate? U is what? X squared. In this case, du is 2x dx. So we have it. This is like idea. Yep. So here, this is changed to the what? Integral 0 root 3 x over. You can change it. 9 plus x to the 4 is x squared dx. You can change it like this. So what's u? U is x squared. You can write g of x. The du is x squared prime dx. So we have 2x dx. Next, divided by 2 because we don't have 2 in integrand. This is same to 1 over 2 du is x dx. This is like idea. So what's that? This is same to integral first one. 1 over 9 plus, what's it like x squared? Here, u. You plug u squared. What is x dx? We have it, 1 over 2 du. 1 over 2 du. One more. You plug 0 into relation of un x squared, un x. You can plug here, g of 0. You plug root 3 into same. Here, g over root 3. This is idea. The next, take out coefficient 1 over 2. 이내거, you plug 0 into x, 0 square is 0. You plug root 3 into x, the root 3 square is 3. 1 over the 9 is 3 square plus u square du. So like this. The next, this is the same to 1 over 2. So was it like this integral? Was it integral 1 over 3 square plus u square du? We can use inverse tangent. So we have 1/3 inverse tangent of u over 3 from 0 to 3. So this is the same to 1 over 6. You plug 3 into u, like inverse tangent of 3 over 3 minus 1 over 6 inverse tangent of 0 over 3. So what's that? Same to 1 over 6 inverse tangent over 1 minus 1 over 6 inverse tangent of 0. What is inverse tangent of 1? What's inverse tangent of 1? Do you have any idea? What's inverse tangent of 1? So what is inverse tangent of 1? Yeah, you're right, pi over 4. So how can you know that? I like this one. Inverse tangent of 1 equals angle theta. You can use definition. So this is 1 equals tangent theta. So which angle has tangent 1? Angle theta is pi over 4. So we have it. So this is 1 over 6 times pi over 4 minus 1 over 6 times. You can use similar method. Inverse tangent of 0 is 0. So this is 0. Final answer is pi over 24. So we have it. This is the whole idea for solving this problem. So like this. So like this. The next thing. Integral e cube e. So similar. You can use substitution rule for solving this problem. What is u? What is u? U is, do you know what is u? You can use substitution for solving this problem. What is u? So what do you think? What is u? Yes, the ln of x. Yeah, ln of x. You're right. U equals ln of x. Du is ln of x prime is 1 over x dx. So you can change it. Here, split 1 over ln of x times 1 over x and replace. Here, u is this one, plug u. The 1 over x dx is only du, so we have it. So next, you can plug e into here, g of e. You plug e cube into here, g of e cube. The next, what is g of e? G of e is ln of e. ln of e is 1. So we have it. What is g cube? You plug e cube into here, the ln of e cube. Crossed out, only 3. So we have it. The next, what is integral 1 over u du? What's integral 1 over u du? Do you know what's integral 1 over u du? Integral 1 over u du is ln of absolute value of u from 1 to 3. So you plug 3 into u, 1 into u, ln of 3 minus 1. ln of 1 is only 0. The final answer is ln of 3. The next one. Here, same, u substitution. U is this one, power x cube. Du is 3x squared dx divided by 3. The 1/3 du is x squared of dx, is right? Divided by 3, like this. So we have it. Next, substitute. The only split 1 over e to the x cubed times x squared dx. You plug x cubed into here is u. So x squared dx is 1/3 du. So we have integral 1 over e to the u times 1/3 du. The factor 1/3, take a 1/3. The 1 over e to the u is e to the negative u du. So do you know this one? So this is like this one. Integral e to the kx. dx is 1 over k e to the kx plus c. So what's that? This is same to the 1 over k is -1 e to the minus u plus c. So we have -1. So we have it. So like this. The next, change back. So here, this u is x cubed into here. That's it. This is the final answer. So -1 over, you can change it to the positive exponent, 3 times e to the x cubed plus c. The next one, how can you solve this problem? How can you solve? The same, we have 5 methods. Integration formula, u substitution, integration by parts, the trigonometric substitution, or partial fractions. So which method is possible for solving this problem? Which method? Which method do you want to use? So which method do you want to use for solving this problem? So which method is possible? Here. So this problem, the u substitution is impossible. One possibility is u equals ln of x. The du is the 1 over x dx, but we have x cubed, so it doesn't work. So we cannot use u substitution. So what's the best way? In this case, we can use integration by parts. We can use integration by parts. How can do that? This is same to integral 1 to e. So we have ln of x times algebraic function 1 over x cubed dx. You can hear ln of x is logarithmic function. 1 over x cubed is algebraic function. So which one is u? Only top one is u. So we have u equals ln of x. The dv is remaining things 1 over x cubed dx. So it's right. This is like a whole idea. What's it like du? du is ln of x prime is 1 over x dx. How can you find the v? How can you find the v? So we can use this idea. What's v? The v is integral 1 over x cubed dx. So we can calculate integral x to the -3 dx. So we have power of -3 plus 1 x to the -3 plus 1 plus c. So this is same to 1 over -2 x to the -2 plus c. So we have the -1 over 2 times x squared plus c. So in this case, you can use integration by parts. You don't need c. You can keep -1 over 2x squared. This is like a z. So what is integral 1 to e ln of x over x cubed? You can use here u times v. U times v is this is diagonal. U times v, the -1 over the 2x squared times ln of x from 1 to e minus integral of v du. The v du is here, v times du. The negative 1 over the 2x squared times 1 over x dx from 1 to e. Second keep the negative 1 over the 2x squared, the ln of x from 1 to e, the one more. You can change it positive. Here, the take out 1 over 2 plus 1 over 2 integral 1 to e 1 over x cubed dx. So what's that? This is same to the like this. The negative 1 over the 2x squared ln of x from 1 to e plus 1 over 2 times, was it integral 1 over x cubed? We have it. Integral 1 over x cubed dx is minus 1 over 2 times x squared. So this is times negative 1 over 2x squared from 1 to e. So we have minus 1 over the 2x squared ln of x from 1 to e. This is same to negative 1 over 4x to the x squared from 1 to e. The next plug the top one and bottom one. The first one minus 1 over 2 times e squared ln of e minus negative 1 over 2 times 1 squared times ln of 1 minus 1 over 4 times e squared minus negative 1 over 4 times 1 squared and simplify. What's ln of 1? What's ln of 1? Do you know ln of 1? ln of 1 is 0. So this is going to 0. So what's ln of e? ln of e is 1. So 1 times minus 1 over 2 e squared is negative 1 over the 2 times e squared. And here minus 1 over 4 times e squared. This is change it plus 1 over 4. You simplify. This is multiplied by 2. We have 4 and 2. The final answer is 1 over 4 minus 3 over 4e squared. So we have it. This is the whole idea for solving this problem. So like this. The next one. The integral x squared times sine 3x dx. So how can you solve this problem? Which method? Which method is possible for solving this problem? So which method? Yes, integration by part. Same. X squared is algebraic function. Sine 3x is the trigonometric function. The integrand is product of algebraic function and transcendental function. So we use integration by parts. So we use this one. So same. X squared is algebraic function. Sine 3x is here. The trigonometric function sine 3x. So what's that? We can use this one. What's u? U is x squared. What's it like dv? The dv is sine 3x dx. Find du. du is 2x dx. How can you find the v? The v is integral sine 3x dx. Integral sine 3x dx is like this one. Negative 1 over 3 cosine 3x plus e. You're right. Yeah, thank you. So we have minus 1/3 cosine 3x. So we have it. So you can use formula. So what's that? So this integral x squared sine 3x dx is here. U times v. So diagonal u times v. So we have the minus 1/3 times x squared times cosine 3x u times v minus integral v times du. So negative 1/3 times cosine 3x times 2x dx. So simplify more. The same to what? The negative x squared times cosine 3x over 3. Change it, positive. You can take out 1/3 and the 2. We have plus 2/3 integral x times cosine 3x dx. How can you find integral x cosine 3x dx? You have to use integration by parts again. The same. X is algebraic function. The cosine 3x is the trigonometric functions. So what's u? 타번. u equals x. The dv equals cosine 3x. What's it like du? du is x prime is 1, just dx. The v is, sorry, this is dx here. Integral cosine 3x is, we have 1/3 sine 3x. So we have a v. So what's that? You have to keep negative x squared times cosine 3x over 3 plus keep 2/3 times u times v, the 1/3 x times sine 3x minus integral, the v times du, the 1/3 sine 3x dx. Okay, the close bracket. This is same to negative x squared times cosine 3x over 3. Distribute 2/3. The 2/3 times 1/3 is 2 over 9 plus 2x sine 3x over 9 minus, you can take out 1/3. The 1/3 times 2/3 is same, 2 over 9. integral sine 3x dx. So what's that? You know what is integral sine 3x dx? Integral sine 3x dx is here. Minus 1/3 cosine 3x. This is minus 1/3 cosine 3x. So what's the final answer? Final answer is negative x squared times cosine 3x over 3 plus 2x sine 3x over 9. The negative 2 over 9 times negative 2 over 9 times minus 1/3 is positive 2 over 27. 2 over 27. 답은 is cosine 3x over 27 plus c. That's it. This is the final answer. for solving this problem. You have to use integration by part twice. This is the whole idea for solving this problem. So, yep, like this. So we have it. The next one. Evaluate sine 5x cosine square of x dx. So do you know, we can follow these 3 steps. Was it like step 1? So this is the same to the like this. So integral. So first one, save one sign. You change sine to the power 4x. You can keep cosine square of x times sine x dx. So you can use substitution. U equals cosine, du is negative sine, minus d equals sine x dx. So one more. You can change sine function to the cosine function. Sine square of x is 1 minus cosine square of x, 1 minus u square. You can change sine to the 4 to sine square of x. How can change? So this is the same to integral sine square of x squared times cosine square of x times sine x dx. So what happens? This is the same to integral. So here, sine square of x is 1 minus u square. You can plug 1 minus u square and squared times cosine x is here, u square. Last one, sine x dx is here, du, minus du, negative du. The next tip. So take out minus 1, the negative integral was 1 minus u square square. You can use Fourier rule. So this is same to 1 minus u square. The square is 1 minus u square times 1 minus u square. You can use Fourier rule. So we have 1 minus 2 times u square plus u to the 4. So times u square du. We have negative integral. This is distribute u square. U square times 1 is u square. So u square times negative 2u square is negative 2 times u to the 4. U to the 4 times u square is plus u to the 6 du. Next, find antiderivative. K minus 1. Antiderivative is 1/3 u cubed minus 2 over 5 u to the 5 plus 1 over 7 u to the 7 plus c. The next, you just only change back. What u? This u is cosine of x. You plug cosine x into u. So we have the 1/3 cosine cube x minus 2 over 5 cosine to the 5x plus 1 over 7 cosine to the power 7x plus c. This is like a final answer. So like this. The next one. Here, integral x squared over 4 minus 9x squared to the power 3 of 2 dx. Do you know how can you solve this problem? How can you solve? So which method is possible? The integration formula, u substitution, integration by parts, the trigonometric substitution, partial fractions. So which method is possible for solving this problem? So do you have any idea for solving this problem? So which method is possible? So this case, so we use we use integration by parts because we have this one. 4 minus 9x squared. This is like a reason. So how can you do that? Here, like this. So what does it mean? You can change this one to the like this. X squared over. You can change 4 is 2 squared. What's 9x squared? Minus 3x squared. Power 3 over 2 dx. So this is what? The constant square minus function square. In this case, 3x is 2 times sine theta. So like this. Divided by 3, x equals 3 over 2 sine theta. Do you got it? This is the idea. So we have this one. The dx is the 2/3 sine prime is 2/3 cosine theta d theta. So we can use identity. The 1 minus sine square theta equals cosine square of theta. How can change? You can change the x squared over 4 minus 9x squared 3 over 2. You plug the 2 sine theta into here. The 2/3 sine theta into here. The dx is 2/3 cosine theta d theta into here. So we have integral the 2/3 sine theta square over 4 minus 3x is 2 sine theta into here. So we have 2 sine theta square to the 3 over 2 times dx is here 2/3 cosine theta d theta. 2/3 cosine theta d theta. This is like whole idea. So like this. So we have it. Now next is simplify. The 2/3 sine theta square is 4 over 9 sine square. What's like the inside one? This inside one is 4 minus 4 sine square. The factor of 4 times 1 minus sine the square of theta. This is like inside one. Do we have it? So next you change it. 1 minus sine square is cosine square. You plug into here. Do we have it? The next simplify. So what's like this one? Bottom one. This bottom one is exactly same to the 4 is 2 cosine theta square is exactly the 4 cosine square to the power 3 over 2. 2 is crossed out. We have 2 cosine theta cube. Same to 2 cube cosine cube theta. The 2 cube is 8. Cosine cube is here. This is idea. You can change it like this. Next, take out. Take out coefficient 4 over 9. The bottom on 8, take out 1 over 8. You can take out 2/3. Take out 2/3 and simplify. Here, 4 is crossed out, 2 is crossed out, 8 is crossed out. 1 over 27 integral sine square over cosine square is tangent square of theta. How can you find integral tangent square of theta? But not easy. You can change it to the identity. 1 over 27 integral secant square of theta minus 1. The next find. What is integral secant square? Do you know integral secant square? What's integral secant square? Do you know integral secant square? The integral secant square is tangent theta. So we have 1 over 27 tangent theta negative theta plus c. The next. So you can change theta variable to x variable. How can you change it? You can use this idea. We have to use this one. We can divide by 2, both sides. We have 3x over 2 equals sine theta. You can draw triangle. So angle theta here. The 3x over 2 is sine theta. 3x over 2. You need to find adjacent y by using Pythagorean theorem. So we have the y squared plus 3x squared equals 2 squared. So we have y squared plus the 9x squared equals 4. Subtract 9x squared from both sides. So we have y squared equals 4 minus 9x squared. Take a square root. The y is, we have square root of 4 minus 9x squared. You plug into here. So y is the square root of the 4 minus 9x squared. Another one. So what's it like theta? You have to use inverse sign. So here, inverse sine of 3x of 2 equals theta. You can use it, right? This is the whole idea. So we have this one, like this. So we can change here. What is tangent theta? Opposite over adjacent. You can keep 1 over 27 times. Tangent theta is opposite over adjacent 4 minus 9x squared. Minus the theta is inverse sine of 3x over 2. So we have inverse sine of 3x over 2 plus c. So like this. Next, simplify. Distribute 1 over 27. So 3 is crossed out. Change like 9. The x over 9 square root of 4 minus 9x squared minus 1 over 27 inverse sine of 3x over 2. This is like answer. The next problem. So this one is the 4x cubed negative 4x minus 3, 3x squared minus x minus 1. You can compare. The top one power is 3. Bottom power is 2. What does it mean? Top one power is the greater than or equal to bottom power. How can you solve? We use long division, and partial fraction. This is the whole idea. Partial fractions. The partial fraction, this idea was a long division. You can use long division first. Here we have the 4x cubed negative 4x negative 3 divided by 2x squared negative x minus 1. How can you do that? We need 2x first. 2x times 2x squared is 4x cubed. The 2x times negative x is negative 2x squared. 2x times minus 1 is negative 2x. The next subtract. 4x cubed is crossed out. The 0 minus is positive 2x squared. The negative 4x minus negative 2x is minus 4x plus 2x, negative 2x. Here, negative 3 is like down. So we have it. Next, we need 1. 1 times 2x squared is 2x squared. 1 times minus x is negative x. Minus 1 times 1 is negative 1. So subtract again. This is same to 2x squared is cancelled. Negative 2x minus negative x is minus x. So negative 3 minus minus 1 is negative 2. So what happens? You can change it. This one to the integral of the quotient 2x plus 1 plus remainder negative x minus 2. Negative x minus 2 over 2x squared negative x minus 1 dx. This is like a whole idea. This is like a long division. This is like the first one, the long division. Next, you have to change this one to the sum of two simple fractions by using partial fraction. This is like a whole idea. So we have the next one. So we have it. The next, this is key. You can use partial fraction. How can the sum replace to the sum of two simple fractions for negative x minus 2 over 2x squared minus x minus 1. Here, you can change factor form is bottom one. The 2x squared minus x minus 1 is 2x plus 1 times x minus 1. You can use partial fractions a over 2x plus 1 plus b over x minus 1. You can then multiply the first one by x minus 1 over x minus 1. Second one by 2x plus 1 over 2x plus 1 by using common denominator 2x plus 1 times x minus 1. The next, distribute a. We have ax minus a. Distribute b. We have 2bx and b. The next, combine. Ax plus 2bx is a plus 2bx. The negative a plus b is here. The next, compare. So this one is original one. What's like a numerator? The numerator is the negative x minus 2 is this numerator. So a plus 2bx minus a plus b. So we can compare. This a plus 2b is coefficient of x minus 1. We have a plus 2b equals minus 1. So constant part minus a plus b is negative 2. How can solve? First, add these two equations. A minus a is 0. 2b plus b is 3b. Equals negative 3. You divide by 3. So we have p equals minus 1. You plug p equals minus 1 into the first equation, second equation, it doesn't matter. I can plug this one into second equation. Plug into here. So we have negative a minus 1 equals negative 2. You add 1 to both sides. So we have minus a equals minus 1. You multiply the both sides by minus 1. So we have minus 1 times minus a is a. Minus 1 times minus 1 is 1. So a equals 1, b equals minus 1. So we have it. So like this. So we are going back to original one. This original one is we have to find quotient plus remainder over this form. You can change it. What's that? This is same to here. A is 1, plug 1 is here. What's B? Negative 1. Plug here. So we have this form. So we have it. The next, take integral. So we have this one is 2x plus 1 plus sum of two simple fractions. So we just only take integral. This is like original one. Take integral. So was it like this one? You split integral 2x 1 here, here. Split everything. The next one. This is very simple. So what's that? This is 2 times, so like this, plus. Integral 1 is x. How can you find? I'm going to use this one. The 2x plus 1 is g of x. What's it like g prime? G prime of x is 2. How can change it? This is like 2, so we use this idea. This one is here, the integral 1 over 2x plus 1 dx, like this. The multiply by 2 here, multiply by 2, and divide by 2. This is a whole idea, like this, is right? Like this. You can change this one to the like this. So here, 2x plus 1 is g of x. This is g prime. We can use this rule. So x squared plus x plus is same to 1 over 2 times ln of absolute value of 2x plus 1, same. This x plus 1 is g of x. This 1 is g prime of x. We can use this idea. So change it. The 1 over 2 is going to power. Change back to radical form, right? So this is exactly same to the ln absolute value of 2x plus 1 to the power 1/2. Change back to radical form. So next, the difference is going to fraction, right? The next one. ln of square root of absolute value of 2x plus 1 over absolute value of x minus 1. That's it. This is the whole idea. The next one. So we think about improper integral for type 1. Case 1. Integral from a to infinity f of x dx. The limit t value approach infinity, integral from a to t f of x dx. Case 2, integral minus infinity to b, we can use similar method. You can replace this minus infinity to the t, so you can replace by t value approaches minus infinity. So improper integral is conversion. What does it mean? If the limit exists. The improper integral is diversion if the limit does not exist. Third case, integral from minus infinity to infinity f of x dx, you can split two improper integral. Integral from minus infinity to a f of x dx plus integral from a to infinity f of x dx. The improper integral is conversion if both improper integral are conversion. The improper integral is diversion. Either one is diversion. This is like a whole idea. The next one, second type of improper integral. Case 1. Discontinuity at b. So here, you can replace the discontinuous point by t value approaches b from the left. This is like true. Here we have a and b. You can choose t value approaches b from the left, the discontinuous point. The second one, discontinuity at a, the same. The replace discontinuous point by t value approaches a plus. Why this is true? The same reason. This is like a, this is b. You choose t value approaches discontinuous point from the right. T value approaches a from the right. The improper integral conversion if the limit exists. The improper integral diversion if the limit does not exist. Case 3. The discontinuity at c. C is between a and b. How can you do that? Split two improper integral with discontinuous point c. integral from a to c f of x dx plus integral from c to b f of x dx. What is integral a b f of x dx converges? The both improper integral converge. The second one, improper integral divergent is either one is divergent. This is like a whole idea. This problem. This is improper integral because infinity things. How can you do that? You can change this one to the next one. Replaced by t value approach infinity. Now how can you calculate this one? You have to use integration by parts. So what's that? This is L-I-A-T-E. Was it like x? X is algebraic function. E to the negative x is exponential function. So in this case, was u? Usually like a top one. U equals x. The dv equals e to the minus x. Find du. du is x prime 1 times dx. So what's v? How can you find v? Integral e to the minus x dx is, what's that? 1 over negative 1 e to the minus x plus c. So we have negative e to the minus x plus c. This is like integration by parts. You don't need c. You keep, this is dx here. So v equals negative e to the minus x. So what's that? This is same to limit. T value approaches infinity. So here, u times v. So we have, parentheses is better. You can use parentheses. So u times v is negative x e to the minus x from 0 to t. So like this. Minus integral v times du. Negative e to the minus x dx from 0 to t. So same to limit. The t value approaches infinity. What's that? You can change it to the positive exponent x from 0 to t. You can change this is positive. So what's integral e to the minus x? Integral e to the minus x is negative e to the minus x. We have negative e to the minus x from 0 to t. So this is same to limit. T value approaches infinity. So you plug t into x, negative t over e to the t minus negative 0 over e to the 0 minus 1 over e to the x. You can change it to the positive exponent from 0 to t. So minus 0 is going to 0. So we have limit t value approaches infinity negative t over e to the t minus plug t 1 over e to the t minus 1 over e to the 0. So what happens? You can use relative rate of growth. T is approaching infinity. What happens to t over e to the t? E to the t is growing faster than t. This whole thing is going to 0. Same. T is going to infinity. E to the t is going to infinity. 1 over infinity is 0. What's the remaining things? The remaining thing is the negative 1 times negative 1 is minus 1 over e to the 0 is 1. Answer is 1. So what does it mean? Answer is improper integral from 0 to infinity x over e to the x dx converges. 2, 1. It's like a whole idea for solving this problem, like this. So the last problem here, integral 3 to 7, 1 over x minus 5 to the 4 dx. How can you solve this problem? Here, you can plug 5 into x. So what happens? 5 is between 3 and 7. You plug into here 1 over the 5 minus 5 to the 4 is 1 over 0 form. What does it mean? Undefined. Undefined. So what's that? So we know this one. Function f of x 1 over x minus 5 to the power 4 is discontinuous. The discontinuous at 5. So 5 is between 3 and 7. This is like the whole idea. So how can you do that? You can split two integrals. 3 to 5. 1 over x minus 5 to the 4 dx. Plus integral 5 to 7. 1 over x minus 5 to the 4 dx. You can split two improper integral, like this. The next thing, how can you calculate this one? You have to use U substitution. U equals inner function x minus 5, find du. Du is x minus 5 prime dx. The 1 times dx is just dx. So next one, integral 3 to 5, 1 x minus 5 to the 4. How can you do that? So you can change this one to the like this. Integral 3 to replace this continuous point by t. 1 over x minus 5 to the 4 dx. Take limit. What happens? Here we have 3, 5. You choose t. The t value approaches this continuous point. T approaches 5 from the left. T value approaches 5 from the left. This is the idea. So like this. Next, U substitution. You plug U into here. So this is same to what? Limit. The t value approaches 5 from the left. Integral 1 over u to the power 4 du. One more. You can plug 3 into here. Change it, g over 3. You plug t into x, g over t. So like this. To calculate, you plug 3 into here. 3 minus 5 is negative 2. You plug t into here. T minus 5 is here. So next, change it to the 1 over u to the 4. You can change 1 over u to the 4 into u to the minus 4. Find antiderivative by using power rule. The 1 over the negative 4 plus 1, u to the minus 4 plus 1 from negative 2, t minus 5. Limit t value approaches 5 from the left. The negative 1 over the 3 times u to the 3 is right. This is same to what? This part is exactly same to 1 over negative 3 u to the negative 3. You can change it 1 over negative 3 times 1 over u cubed. Same to what? The negative 1 over 3 times u cubed. You can change it like this. The next, you plug t minus 5 into u. We have minus 1 over 3 times t minus 5 cubed. You plug minus 2 into u. The negative 1 over 3 times minus 2 cubed. What's the right answer? Here. T-value approach is 5 from the left. You plug into here. What happens? Minus 1 over 0 form. What's the top one? The minus 1 is like a negative. The T-value approach is 5 from the left. T-value approach is 5 from the left. You can choose test number 4.9. You can plug 4.9 into T. The 4.9 minus 5 is minus 0.1. The minus 0.1 cube is negative number. The negative number times 3 is the negative number. We have minus over minus. What does it mean? We have positive infinity. So what's that? This is the improper integral is divergent. This is like a whole idea for solving this problem. Okay, this is all for today's lecture. So do you have any question? Do you have any question? Okay, you're welcome.